Here's a stick. It is 1 meter long. 1 meter is a measure of length for one-dimensional measurements. And here's a dog sitting inside a square where the width is 1 meter and the length is also 1 meter. Length times width is 1 meter times 1 meter. So this square has an area of 1 square meter. 1 square meter is a measure of area for two-dimensional measurements. Notice that squaring a one-dimensional measurement will give us a two-dimensional measurement. Here are 5 fifth graders hanging out in a cube, where the width is 1 meter, the length is 1 meter, and the height is also 1 meter. Length times width times height is 1 meter times 1 meter times 1 meter. So this cube has a volume of 1 cubic meter. 1 cubic meter is a measure of volume for three-dimensional measurements. Notice that cubing a one-dimensional measurement will give us a three-dimensional measurement. Here's an apartment with an area of 23 square meters. Sounds really tiny. What would this measurement be using feet in the English system? First, we need to know information on the relationship between meter and feet. Looking up a table of common measurements, we see that 1 meter equals 3.281 feet. Also note that our starting unit is squared meters and our ending unit is squared feet. But 1 meter equals 3.281 feet relates two different units of length for one-dimensional measurements. How can we build a math tunnel to take us from squared meters to squared feet, where the measures of area are two-dimensional measurements? So, for the conversion factor, if we put feet in the numerator and meters in the denominator, then we have a one-dimensional ratio. Remember, the meter is one-dimensional, but a square meter is two-dimensional, which is meter times meter. And if we try to cancel these two units, we end up with meter times feet. I mean, what the factor is that? So here, we need to square the one-dimensional ratio to get a two-dimensional ratio. Now, square the whole fraction, which literally means multiply the fraction by itself 2 times, and we will get feet times feet in the numerator, which is square feet, and meter times meter in the denominator, which is square meter. Now, we can cancel the square meters, leaving square feet as the only unit, which is what we want to end with. Go back to the conversion factor when we only had feet in the numerator and meters in the denominator. Knowing that 1 meter equals 3.281 feet, place the same numbers into the ratio we have. So, in the numerator, 3.281 times 3.281 is 3.281 squared. Feet times feet is square feet. And in the denominator, 1 times 1 is 1 squared. Meter times meter is meter squared. To plug these numbers into our calculator, take the starting number, 23, multiply it by all the numbers on the top, and divide the answer by all the numbers on the bottom. Since the first measurement has 2 significant figures, and the conversion factor has 4 significant figures, the final answer can only have 2 significant figures. Therefore, round 247.594 to the tens place, which is 250. Remember, 250 with no decimal place has 2 significant figures. 250 with the decimal place has 3 significant figures. That's kind of confusing. We'll just write 250 using scientific notation. So the answer is 2.5 times 10 to the second. Now it is crystal clear the answer has 2 significant figures. By the way, were you expecting a smaller number or a bigger number in square feet? Since there are a lot of feet per meter, getting a much bigger number in square feet makes sense. Pop quiz. Which relationship can be used to convert a measurement from meter squared to centimeter squared? A, 1 centimeter squared equals 0.01 meter squared. B, 1 meter squared equals 100 centimeters squared. C, 1 meter squared equals 10,000 centimeters squared. Or D, 1 centimeter squared equals 0.0001 meters squared. Here's an average apartment-sized fridge. It has a volume of 209,545 cubic centimeters. Sounds huge, right? What would that be in cubic meters? First, we need to know information on the relationship between centimeter and meter. Looking up a table of common measurements, we see that 1 centimeter equals 10 to the negative second meters. Also note that our starting unit is cubic centimeters, and our ending unit is cubic meters. But 1 centimeter equals 10 to the negative second meters relates two different metric units of length for one-dimensional measurements. How can we build a math tunnel to take us from cubic centimeters to cubic meters, where the measures of volumes are three-dimensional measurements? So, for the conversion factor, if we put meter in the numerator and centimeter in the denominator, then we have a one-dimensional ratio. Remember, the centimeter is one-dimensional, but a cubic centimeter is three-dimensional, which is centimeter times centimeter times centimeter. And cubic meter literally means meter times meter times meter. Just like before, when our starting unit and the conversion factor have different dimensions, we will need to cube the one-dimensional ratio to get a three-dimensional ratio. Now, cube the whole fraction, which literally means multiply the fraction by itself 3 times. And we will get meter times meter times meter in the numerator, which is cubic meters, and centimeters times centimeters times centimeters in the denominator, which is cubic centimeters. Now, we can cancel the cubic centimeters, leaving cubic meters as the only unit, which is what we want to end with. Knowing centi means 10 to the negative second, which has a negative exponent, and centimeters are smaller than meters, placing 10 to the negative second next to the meter will make it smaller and equivalent to 1 centimeter. So, in the numerator, 10 to the negative second times 10 to the negative second times 10 to the negative second is 10 to the negative second cubed. Meters times meters times meters is cubic meters. And in the denominator, 1 times 1 times 1 is 1 cubed. Centimeters times centimeters times centimeters is cubic centimeters. To plug these numbers into our calculator, take the starting number, 209,545 centimeters cubed, multiply it by all the numbers on the top, and divide the answer by all the numbers on the bottom. Since the first measurement has 6 significant figures, and the conversion factor is an exact number by definition, the final answer can have 6 significant figures. So the answer is 2.09545 times 10 to the negative 1 meters cubed. By the way, were you expecting a smaller number or a bigger number in cubic meters? Since there are a lot of centimeters per meter, getting a smaller number in cubic meters makes sense. Pop quiz. What relationships can be used to convert a measurement from centimeters cubed to kilometers cubed? A. 1 centimeter cubed equals 10 to the negative 6 meters cubed. B. 1 kilometer cubed equals 10 to the 9th meters cubed. C. 1 centimeter cubed equals 10 meters cubed. D. 1 kilometer cubed equals 10 meters cubed.